You know, when we talk about AI, we get so obsessed with what the machine decides, but we're completely missing a much more dangerous question. When does it get to make that decision permanent? Today, we're diving into an architecture designed to prevent AI from making its biggest and most irreversible mistakes.
And this quote right here, it absolutely nails the problem. See, the real damage from AI usually doesn't come from just a wrong answer. It comes from a system that takes a maybe, an uncertain guess, and slams it down as a permanent, done deal way too fast, locking in that mistake forever. All right, so here's our game plan. We're going to walk through 5 key ideas. We'll start by unpacking this problem of rushing to judgment, then we'll look at the environment that actually causes it. And from there, we'll build up a really powerful architectural solution, step by step. And I'll show you why this isn't just about safety, it's about a massive competitive advantage.
Okay, let's dive right in. The crisis of premature closure. In our race to build faster, more automated systems, we've started to confuse speed with efficiency. But what if that speed has a massive hidden cost? What if the cost is locking in a terrible decision with absolutely no way to hit undo?
So picture this, a digital assembly line moving super fast. And AI is looking at a potential solution. Let's call it a candidate. Right now it's still glowing. It's filled with possibility. But the system forces a choice. Commit or discard. Now. And in that instant, the candidate hardens into a solid block. And all the other possible paths, maybe even better solutions, just vanish. Poof. That's the destruction of alternatives.
So why does this even happen? Well, it's because AI systems are operating in what we can call the fog of finite conditions. They never, ever have a perfect, complete picture of the real world. And here's the kicker. This isn't some bug we can just patch. It's a structural reality we have to design our systems to handle from the ground up.
This fog is basically made of 4 core limitations. First, there's finite observation. The AI sensors and its data are always incomplete. Second, finite evaluation. It can be incredibly expensive or take way too long to actually verify if a decision is right. Third, finite execution. Once an action is taken, like a robot arm pushing a button, it might be literally impossible to stop. And finally, finite responsibility. When something inevitably goes wrong in a complex system with humans and machines, who's actually on the hook?
So when you mix all those things together, what do you get? You get this: irreversible loss. This is what happens when that premature commitment leads to real, unrecoverable damage. And the key thing to get here is that this isn't just a model being a little inaccurate. No, this is a fundamental failure of the system's architecture.
Okay, so if the problem is baked into the architecture, then the solution has to be architectural too, right? This is where we pivot, from just talking about the crisis to actually building the solution. We need to design systems that have the built-in wisdom to know when to wait, when to ask for help, and crucially, when to turn back.
In this architecture of prevention, it really boils down to 3 simple but super powerful ideas. Number 1, defer, giving the system the power to just wait when the decision isn't justified yet. 2, reassign, giving it the power to escalate, to ask for help. And 3, restore, giving it the power to rewind to a previous state without having to start all over from scratch.
All right, let's break these down, starting with defer, or what the source material calls deferred evaluation. Instead of forcing that binary yes or no choice, the system creates a third path, hold. Think of it like a preservation chamber. An uncertain idea is kept alive and active until the conditions are finally right. This isn't just passive waiting. It's an active refusal to jump to a conclusion.
Next up, reassign. The big idea here is to separate what the decision is from who gets to approve it and when they get to approve it. The AI is fantastic at generating options. That's the what. But the authority to approve, stop, or escalate that decision, that should probably rest somewhere else, often with a human. That's the who and when. This dynamic shift of authority is absolutely key to preventing a single automated step from having too much power.
And finally, there's restore. Because let's be honest, exploration without a safety net is just a gamble. What's the point of letting an AI try new things if it can't go back when it hits a dead end? A truly intelligent system needs an undo button, and this architecture gives it one. It lets the system jump back to a previous valuable state, like going back to a fork in the road, without losing all the progress it made along the way.
So, okay, we've got these 3 new powers, the ability to wait, to ask for help, and to go back. And when we bring these principles together, we move out of a world of blind, reactive decisions and into a world of governed, deliberate commitment. The system now has to actually earn the right to make a choice irreversible.
Which, of course, leads to the million-dollar question. After all this waiting and reassigning and restoring, when does the system finally get to make a decision permanent?
Well, a commitment is only justified when that potential decision can pass through 4 crucial gates. First, can we fully evaluate it right now? Second, is the state restorable? Can we undo this if we're wrong? Third, does the correct authority, be it human or another system, actually approve this? And finally, is it crystal clear who is responsible for the outcome?
It's only when you get a yes to all 4 of those questions that you achieve what's called governed commitment. This is the capstone, the pinnacle of our architecture. It transforms commitment from a blind reaction into the final justified output of a deeply disciplined process. It's where safety and intelligence finally work together.
Now let's zoom out for a second, because this architecture isn't just some niche solution for a few safety-critical systems. This is a fundamental shift in how we should be thinking about building AI that actually works. It's a whole new axis of competition.
I mean, think about it. Semiconductor design, autonomous driving, cybersecurity, legal contract review, scientific discovery. On the surface, they all look totally different, but underneath, they share the exact same problem. Evaluating a choice is expensive, and making the wrong choice too early leads to catastrophic, irreversible loss. They're all part of one big, unified problem class.
And that, right there, leads us to the big takeaway of this whole thing. The next great leap forward in AI won't just be about models that are a tiny bit more accurate. It's going to be about building architectures that are smart enough to preserve the value of exploration, the value of not knowing yet until a decision is truly fully justified.
So I'll just leave you with this one question. As you look at the AI systems you build or use every day, ask yourself this. Is it just built to decide as fast as possible, or is it actually designed to understand when a decision is truly justified? Because the difference between those two, well, that's everything.